The concept of a breakthrough fighter arose during World War II, similar to the concept of a long-range escort fighter. Both are types of aircraft that can carry out long-range combat missions, and the famous P-51 Mustang fighter belongs to this category. In 1945, Lockheed responded to the Army's requirement for an advanced long-range jet fighter and began developing the XF-90 jet fighter, which later evolved into the XF-90, an early long-range breakthrough/escort fighter. The early design of the XF-90 incorporated some of the design of the P-80 fighter, adopting a low monoplane wing and air intakes on both sides of the fuselage, but the P-80 did not have a swept wing suitable for high-speed flight. The leading edge of the XF-90's wing was swept back 35 degrees, as was the leading edge of the horizontal tail, giving the fuselage a more slender and pointed nose. The original power system used Lockheed's own L-1000 axial flow turbojet engine, which was not very successful and was later replaced by the Westinghouse J-34 engine. A total of 2 prototype aircraft were built, with the second aircraft featuring an afterburner, making the XF-90 the first U.S. fighter aircraft to have a true afterburner. The 2 engines were installed side by side in the rear section of the fuselage, providing a thrust of 27.6 knots. Due to the use of new structures and materials, the aircraft's empty weight was relatively heavy, about 8,200 kilograms, and these 2 engines could not allow the aircraft to fly at supersonic speeds, with a maximum speed of about 0.87 Mach. However, the aircraft could achieve supersonic speeds in a dive and acceleration, reaching up to 1.12 Mach during tests. The new structure also had its advantages, as the aircraft was very sturdy. 2 prototype aircraft, the XF-90 and the XF-90A, were built, with the XF-90A being used in a ground nuclear explosion test in April 1952. Despite being only half a mile away from a relatively small for Malawian Kwacha's nuclear bomb explosion, the aircraft wreckage was not fatally damaged. After repairs, it could still be used, and this aircraft endured a total of 3 nuclear explosion tests, with its wreckage later recovered and decontaminated by the Air Force Museum. The range was a strict standard for the XF-90, with internal fuel tanks in the fuselage and external tanks mounted on the wingtips to increase the total fuel capacity to 1,665 gallons, giving the aircraft a maximum range of nearly 3,700 kilometers, which was quite impressive for early jet fighters. The pilots had a bubble-shaped pressurized cockpit with a rear-sliding canopy and ejection seats installed. The A-1B sight could be used for aiming the aircraft's cannons and rockets. The aircraft's weaponry was quite extensive, with 6 fixed 20mm cannons and a total of 1,602 rounds of ammunition. The aircraft could also carry 8 5-inch unguided rockets and up to 2,000 pounds of bombs, with the largest being a single 1,000-pound bomb. The XF-90 fighter had a strong range and firepower, but its power was too weak, which was a critical reason for the military's rejection of it. Supersonic flight was almost a strict standard for 1950s fighters, which the XF-90 could not achieve. The first aircraft, without an afterburner, could not even take off at full load, requiring either the use of rocket boosters or a reduction in payload. Only the second XF-90A aircraft could take off solely under its own power. Neither of the 2 prototype aircraft were preserved, with the first one being used for ground static tests and destroyed in 1953, and the second one being destroyed in a nuclear test. Only some parts of the second aircraft were recovered and displayed.